Okay, good afternoon to one and all. Welcome back to another session of our online class. As you all know, in our last class we have discussed about network types. In some of the network types, we discussed about was LAN, MAN, WAN, PAN, WLAN, and so on. Right. So I hope people can still remember all those different types of network, and you have also viewed the recorded video that I have sent you people. Now, I will start today's class with discussion on network architecture. Now, network architecture describes how a network is arranged and how the resources are coordinated and shared. Right? So, network architecture is divided into two parts: topology and strategy. So, today I'll discuss on topology only. Now, there are different types of topology, but before going on to different types of topology, let's see what is topology. It says network topology describes how a network is configured and arranged, how the network is set up. Right? There are different types of topology. Yeah? So some are, for example, star topology, ring topology, also hybrid topology, and so on. So we'll be looking at all these types soon. Strategies define how resources are shared. Right? So network topology describes how network is configured and arranged, but strategies define how resources are shared. How resources are shared from one computer to another computer. How resources is shared from the server to the clients. Right? So that's what strategies define. Now, looking at topologies, there are 6 different types of topologies we will look at, which is bus, ring, star, tree, hybrid, and mesh. So we'll look at each one of the it says bus topology. In this type of network, each device in the network handles its own communication. There is no host computer or server, and all communication travels along a common connecting cable called a bus. Now, remember, bus will follow the the normal bus that goes on the road. It will just follow the road, right? So that's why this type of topology's name is called bus, because the information will follow a path, only one path, and it will just keep on following the path, and it will go to the uh, the destination, the right destination. It will not go to every person. Everyone will not be able to see everything that is sent from one computer to another, right? It will remain in the queue, and once it reaches destination, then it will go to the computer. Right? It says this arrangement is common in systems for electronic mail or for sharing data stored on different microcomputers. So let's see, how does communication occur? As information passes along, it passes along the bus. It is examined by each device to see if the information is intended for it. So see, for example, there are so many computers in one room, right? All are connected in a bus network, right? It is a bus topology. So if computer A is sending information to computer D, right? So computer A will send the information. Now it will go along the bus, right? And then it will go to computer B. Right? That information will go and see, oh, this message is not intended for computer B. Then it will go to computer C. It will check whether it's intended for computer C. If no, then it will C, and then it will see, oh, this message is for computer D. Then computer D will be able to view the message and receive the message. See, computer B and computer C will not be able to receive the message because it's not intended for it. See, the message is not sent for them. Right? Now, this is how a bus topology looks like. As you can see, right, the 4 microcomputers are linked in a bus where see, this is the network gateway, right? Maybe switch, right? So network gateway is here. Now everything is connected along a bus in a line, just like when you go to the road, you will see houses on either side, right, on the right and left. Similarly, in bus topology is similar thing. Now information is going in a line. The information is in the seva here. It goes to the seva and so on. It goes in the travels in the line, right? And then if you send information from one computer to another computer, it will go in a line and it will take some time and reach to the right computer. Now, if you see this properly, right, try to understand. See, let me see. Right now, see, so this is a bus topology, right? The printer is there, 4 computers are there, and it is connected in a bus network. Now, this PC is saying hi to PC3, this PC, right? So when he says hi to this PC, what will happen? The message is going along this path. It will go to this PC first because this is this PC. It will meet first. It will see this PC. Oh, then this PC will say it's not my message. So it will give that message back, and then it will again go along the path, and then it will go to this PC, and this PC says, oh, it's my message. Then it will receive it. See, just like when you travel in the bus, right, by the road, right? So wherever you want to drop, right, you will pull the bell and the driver will stop, and then you get off and go to your house, right? So you will not get off at someone other's places, right? You will get up beside your house, right? Yeah. Or beside the road to uh, which goes to your house. See, so that's how it works, right? And next one, when to use bus topology? When only a few microcomputers are to be linked together, the network's efficiency decreases as the number of microcomputers network increases. So if there are only few microcomputers to be linked, it's better. It's very easy to set up bus topology. If there are many computers, more than 10, then bus topology is not a good network setup method. Right? You should not arrange the networking under bus topology. Now there are some advantages and disadvantages also bus topology. Bus topology is very easy to, it's very cheap and it's easy to install. It allows different microcomputers to share data and information. Right? Those are two advantages of bus topology. Disadvantage: a bus network is not as efficient as the star network because it does not contain a direct link to the resource. See, and then performance decreases, the number of computers increase. So that's the disadvantage of bus topology. Because if more computers, if you are using more computers, then the amount of time it will take one message to go from one computer to another computer, it will be too much more. It will take a lot of time. Right? And unlike star topology, star is topology is best. So star topology is directly connected to the main server, right? So transferring of data will be very fast. Only thing in bus topology, what will happen when you send information from one device to another, it will travel along the bus, along the line, see that to check whether that information is intended for that PC or not. Okay? If it is for that PC, then it will go. So it will take time to check every PC. But for other topologies, star topology, it will not take time. It will go direct to the PC to which the message is intended to. Now, let's look at the next one, which is ring network topology. It says ring network is where each device is connected to two other devices. In this configuration, there is no central server or no or host computer. There is no server, no host, right? And a ring will be formed. Right? These computers will be connected in a ring form. Communication messages are passed around the ring until they reach their correct destination. Now this one also, right? It will go to every computer unless and until it reaches the right destination. So let's see. See, so there are 5 computers here. If this computer is sending information to this computer, right? So once this will send information, it will go to this computer, then this one, then it will reach here. See, It will take time. It will go to every computer that is along the way, and then it will reach the and then the information will reach the right computer, the right device, right destination. Right now, when to use ring topology? It is often used mainframe computers, that is servers, host computers of a wide geographical areas. A ring network is useful in a decentralized organization because it makes possible a distributed data processing system. In this system, computers can perform processing at their own displaced locations. However, they can also share programs, resources, and information with each other at all times. See, so if there is no centralized seva or nothing, I mean, it's not a big organization, right? And there is no need for lot of data to be stored at a central place. Then it's better use a ring network, right? So that it's easy to set up and easy to share information, right? Even though it will take some time to share information, but setup will be very easy, and it will not be that costly. Advantage: computers can perform own displaced locations. So that's the advantage, right? You can computers can perform their task at their own locations wherever it is placed. They can perform the task. It can also share programs, data, and other resources with each other. So sharing is possible in ring network, right? And then another advantage is it can perform their own task at their own displaced locations, right? It doesn't have if uh, it doesn't need the seva, because there is no seva, so it's not dependent on the seva. It can work on its own. The computers can work in its own and then do their task. Disadvantage: messages are passed around until they reach the correct destination, therefore makes communication slow. So there's the disadvantage, right? Message will pass from one computer to another computer to third computer unless until it reaches the correct destination, and it makes communication slow. Computers linked together could easily be infected with virus, so that's one threat. And then if ring is broken or not working, then communication is down. That means out of 5 computers that are connected, if one of the computer is uh, not working, then communication breakdown will occur, right? That means information sending from one computer to another computer will not occur, right? So in ring network, all computers have to work, then communication will be possible. Next one, a very important one, star network topology. In a star network topology, a number of small computers or peripheral devices are linked to the central computer or switch. See, so you can see this central computer can be the host computer or a seva or a switch. So the central computer is in the middle. It can be a seva, it can be the host computer, or it can be the switch. Other computers will be connected to this seva, right? Host computer seva, right? Now, anything you want to send, right? For example, this computer wants to send information to this one. It will go direct to this seva, and the seva or the host computer will send the information to this computer. See, it will take it will not take much time to send information, right? It's not that it will go from this computer to this computer to this computer and so. No, it will just go to the seva, from seva direct to the destination. When a node sends a message, it first goes to the switch, which then verifies and forwards the message to the correct destination device, as I discussed earlier. Star network is the most widely used network topology in the world. So mostly star network is used, right? Even in our computer lab, we are using star network, and then you can see, right? Sorry, you can see this one, right? Do you have a message to send, right? It says now, do you have a message to send? Yes. See, so communication is just between that computer, right? Computer to the seva, right? And then seva will communicate with all the computers, right? So you can see the seva will communicate with the will help other computers to communicate. Right? Things will be sent from one computer to the server. From the server, it will go to the other computer. Now, advantages. It can be used to provide a time-sharing system. That is, several users can share resources on a central computer. So, time sharing meaning a lot of time will be saved and shared. Why? Because in the central computer and the server, you can put all the resources, right? For example, in our school, in the lab, right? If there is a server, right, I can put all the computer notes and everything, all the worksheets in that server. So, and I will link all the computers that are there to that server. So, you will be able to access things from the server. Right? Things will be stored at only one place. It's not that I'll have to um, put the notes in every individual PC. No, just it will be in the server, and then a link will be created, and you will be able to view that notes and whatever resources are available in the server. And it is efficient and allows information and resources to be shared with other terminals. Right? That's another disadvantage is it is expensive to install or set up a star network. It is expensive because a lot of cables are needed, and then the central seva or house computer is costly, right? And then it says if the house computer is down, then the entire network is down. So that's another disadvantage. If the seva is down, then the whole network will be down. There's the disadvantage. But if the other computers, if the seva is working and one of the computer is down, still the network will work. Right? But only everything is dependent on the seva. If seva is down, then the whole network will be down. Right now, looking at the tree network, this is another name for tree network is hierarchical network. Each device is connected to another device which may be connected to other devices. It forms an upside down tree where the root device is usually the most powerful. Right? You must have seen the trees, right? Root and then the branches on top. So it will be upside down tree. Okay? You'll see the diagram very shortly. See here. Right? Now the branches are at the bottom, right? Followed by the root on top. Right? So the top one, the first computer here is the most powerful one. Right? For example, this is the main server. Now things are shared with two other servers. From this server, it goes to this server and this server. Now this server is saving these three computers, and this server is saving these two computers. See, this is a hierarchical network whereby there's one main server, and then that main server is linking to other servers, and those servers are connecting to other nodes. A hierarchical network topology is useful in decentralized organizations. Example, I have individual microcomputers connected to departmental microcomputers, that is host. These mini computers in turn may be connected to the organization's mainframe server computer, which contains data and programs to be accessed by all. So this is workable, this is applicable in this not decentralized, in centralized organizations. Centralized organizations where there is a need for server, right? Where there is need for lot of data, lot of information to be stored. Okay? Then you need a server, and then lot of all the information will be in the server. Some of the information will be shared with other two servers, right? From one server to another two servers, three servers, and then those servers will provide information or resources to the other computers. Now, advantage, the hierarchical topology allows various computers to share databases, processing power, and different output devices. And disadvantage, if the host computer server fails, the entire network is disabled. Right? So again, same thing, if the host computer server fails, if the main server is something goes wrong with it, the whole network is disrupted. And then it is expensive to install or set up a star network. Very expensive to install or set up a star network. Now, hybrid network is a mixture of all other topologies. That means mixture of ring, star, bus, right? All those topologies, if you mix, it becomes a hybrid network, right? Big organizations have lots of smaller networks based on different topologies, which are then interconnected. So, for example, there is a one big organization. It is accounting department. It is marketing department, right? Uh, it is sales department, and so on. So many departments are there. Example, accounting department has 5 computers. Sales department has 2 computers, right? And finance department is the 3 computers, and so on. So it will all depend the number of computers each department has, right? So depending on the users and the number of computers that each department has, uh, different type of network is set up. So you can see, for example, in USP has 12 member countries, and each campus there are several computer labs. Each of these labs are set up using the star configuration, which then is connected via backbone cable, microwave dish, and satellite, forming a tree and mesh network as well. Right. So let's see here. See, this is an example of a hybrid network. Right. You can see a ring network is here in the same setup. See, main server is here, and this is connected to the switch, right? The router and the switch. Right. And then using that router, for example, this is in Latoka campus USP, right? And this one is in Suva campus, right? Then bottom one, and the other two maybe somewhere else, maybe in Ba and Tavua. See, so different places, different type of setup is used, right? Laudala campus, see, a big setup is there because uh, most of the things, most of the courses are in Laudala campus is the main branch, right? Just an example, right? This is just an example, right? So main server is here, and it is connecting to different places using different topologies, right? This is a hierarchical topology. This is a tree topology. Yeah, this is a tree, right? This one is a bus topology, right? And then this is a ring, and this is a star, right? I hope you have understood. Now, moving further on, advantage. Hybrid network is flexible, that is can be designed according to the requirements of the organization by optimizing the available resources. Disadvantage, it is complex design, difficult to set up, right? So it is a complex design because lot of topologies, different topologies are linked together. The hubs used to connect two distinct networks are very expensive. See? So very expensive because the hubs that are used to link networks are expensive. Now, last one is mesh network. There is no particular configuration. Rather, the devices are connected to each other on the fly, especially in the wireless domain. It is best suited for WLANs and so mesh network. It's the network is arranged in not any order. And let's see. See, mesh is just anyhow the network is arranged, right? So one computer is connected to this one is that one, and so on. Anyhow, the computers are arranged. It's not a ring. It's not a star. Right? It's not a hierarchical, but it's a mesh network where network is arranged in anyhow, any order. Advantage, expansion and modification in topology can be done without disrupting other nodes. So that's the advantage. If it is arranged anyhow, you can expand network very easily. If one of the components fails, there is always an alternative present for data transmission. See, so if one computer will fail, for example, right? If one of the computer will fail, then some other computer will give you the information because every computer is connected to two different computers. See, this computer is two computers. This computer is connected to two computers. This one also two computers. Every computer is connected to two different computers. If one will fail, that computer will take information from other computer. See, disadvantage, redundancy in many of the network connections. High cost of this network compared to other network topologies. So it's a high cost It's very high cost. I mean, it's very expensive to set up. It is difficult to set up and maintain the network. Why? Because it's arranged anyhow, so very difficult to maintain and set up. Now I will show you one small video.
Network topologies. So that's what we're going to talk about in this video. Now, a topology is the layout of how a network communicates with different devices. There are a couple of different categories of topologies. There's wired and wireless. So we're first going to talk about the most common wired topologies. And the most common wired topology that's used is this topology. Now, in a star topology, all computers are connected to a central wiring point, such as a hub or a switch. All data on a star network passes through this central point before continuing to its destination. Now, one of the major benefits of this topology is that if one computer failed or if there was a break in the cable, the other computers would not be affected because each computer has their own cable connection. However, a disadvantage of the star topology is that if the central hub or switch fails, then all the computers on that central point would be affected. And this is called a single point of failure. If this happens, the entire network goes down. Another type of topology is called ring. The ring topology is a type of network configuration where each computer is connected to each other in the of a closed loop or ring. So every computer on this ring has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. Now, this kind of topology is very old and is rarely used today. Now, the advantage of a ring topology is that they are easy to install and easy to troubleshoot. However, the disadvantage would be that if just one of these computers goes down, or if there was a single break in the cable, then all data flow would be disrupted. And the next one is the bus topology. The bus topology is very old technology, and like the ring topology, it's not used today that much. This is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. And this backbone is a coaxial cable. The computers connect to this cable using special connectors called BNC, which are also known as T connectors. One of the advantages of the bus topology is that it is also fairly cheap and easy to implement. However, a disadvantage of the bus topology is that it requires that the cable be terminated at both ends using terminators. In order for this setup to remain operational, there must not be any open connections, including the ends that attach to the computers. So if a computer is removed or if the terminators are loose or missing, then the cable would be open and then data would bounce back. And this bounce is known as signal reflection. And if this happens, data flow would be disrupted. And there is also the mesh topology. Now, in a mesh topology, each computer on the network is connected to every other computer on the network. So by having so many connections, it handles failure very well. In this illustration, there are 4 computers with 3 connections on each computer, which makes a total of 12 connections for this network. Now, the advantage of a mesh topology is that it creates a high redundancy level, because if one or more connections fail, the computers would still be able to communicate with each other. However, because of the amount of cabling and network cards that have to be used, mesh topologies can be expensive, so they are rarely used on local area networks or LANs. They are mainly used on wide area networks like the internet. In fact, the internet is a good example of a mesh topology because the internet is made up of numerous routers all over the world that are connected to each other to route data to their intended destination. So even if those go down, the data will get rerouted using a different path to ultimately reach their destination. So the internet is very redundant because it's using a mesh topology. So now we're going to talk about wireless topologies. So let's start with the infrastructure wireless topology. Now this topology uses a combination of wired and wireless devices. Now this is very similar to a star topology, where you have wired devices such as these computers here physically connected to a switch. And you also have a wireless access point that's also connected by a cable to the same switch. The wireless access point is here so that wireless devices such as laptops, tablets, cell phones, etc. can connect wirelessly to the network. So the wireless access point acts as a bridge between the wireless network and the wired network. Now the infrastructure topology is not limited to a single wireless access point. In fact, you can have multiple wireless access points if you want. It just depends on the needs of the network. And the next wireless topology is ad hoc. Ad hoc is a very simple wireless topology. And it's simple because it doesn't rely on any infrastructure, such as cables, routers, servers, or wireless access points. All the devices in an ad hoc network wirelessly connect to other devices in a simple peer-to-peer network. They directly connect to each other without using a centralized device, such as a Wi-Fi router or access point. And because they directly access each other without a server or router in between, each device is responsible for its own security and permissions. Ad hocs are used for setting up a quick wireless network on the fly where devices can share data without the need of an existing wireless network. And the last wireless topology is called a wireless mesh. Wireless mesh topologies are similar to wired mesh topologies, where devices are interconnected with each other, but with the exception that they are wirelessly interconnected. So for example, let's say you wanted to deploy multiple wireless access points all throughout a building so that wireless devices that are in different areas are able to access the internet. So normally you would have a modem that brings in the internet to the building. And then you would also have a switch that's connected to the modem. And then you would connect each wireless access point with a cable to the switch. So by doing it this way, this requires extra cabling, and it would also require extra time running the cables through the building. So this is more expensive and more time consuming. Now, a wireless mesh topology would be similar to this setup, but without the need of these extra cables. In a wireless mesh, each wireless access point will talk to other wireless access points to create a seamless internet connection for wireless devices to connect to. So if this laptop over here wanted to access the internet, it would connect to the nearest wireless access point, and then this access point would relay the connection to the next access point, and then to the next one, and then eventually find its way back to the modem. So no matter which access point that you're connected to, you will still have internet access because all the access points are in constant communication with each other and the modem. And even if one or more access points were to fail, it wouldn't matter because the access points will reroute the data. So a wireless mesh topology is very redundant because the internet connection is spread out over many wireless access points.
Right, thank you for watching the video. I will end the class here. I will not discuss further on network strategy. Network strategy I will discuss in our next class. Right now, I'll give you people chance. If you people have time, if you people want to ask any questions regarding the worksheet or something else regarding the class, you can ask me now.